Today's lesson is about review for geometric sequence and a series. 3a. A hydraulic hammer drives a metal post vertically into the ground by striking the top of the post. The distance that the post is driven into the ground by nth strike of a hammer is d sub n. The distance d1, d2, d3, and dn form a geometric sequence. The distance that the post is driven into the ground by the first strike of the hammer d1 is 64 centimeters. The distance that the post is driven into the ground by the second strike of the hammer d2 is 48 centimeters. Find the value of a common ratio for this sequence. The common ratio equals d2 over d1. That is 48 over 64. Reduce. You will get 3 over 4. Let's go to 3b. Find the distance that the post is driven into the ground by the 8th strike of the hammer. For geometric sequence, we got to use this formula, u sub 8. So every single n you got to turn into 8. u sub 1 times r to the 8 minus 1's power. So we plug in 64 times 3 over 4 to the 7th power equals. You will get 8.54 centimeters. 3c. Find the total depth that the post has been driven into the ground after 10 strikes of the hammer. We are looking for S sub 10. Since this r equals 3 over 4 less than 1, we use this formula. It will be 64. 1 minus 3 over 4 to the 10th power over 1 minus 3 over 4 equals. Answer will be 242 centimeters. Let's go to 4a. 512 competitors enter round 1 of a tennis tournament in which each competitor plays a match against one other competitor. The winning competitor progresses to the next round, round 2. The losing competitor leaves the tournament. The tournament continues in this manner until there is a winner. Find the number of competitors who play in round 2 of the tournament. According to this given information, we know that after one game, half of the competitor will leave while half of the competitor will stay. Therefore, we could say this is a geometric sequence. We have 5, 12. Then you divide it by 2, you get the 256. Then you divide it by 2, you get the 128, and so on. Therefore, we know that r equals 1/2, and u sub 1 equals 512. We are looking for u sub 6. Using this formula, you will get u sub 1 times r to the every single n turning into 6, 6 minus 1. So you have 512 times 1/2 to the 5th power, that is 16. Let's go to 4b. Find the total number of matches played in this tournament. We are looking for total number of matches. We didn't say how many tournaments they played. It's the total number of matches. Very beginning we have 512. Then they will play 256 matches. Then they will play 128, 64, 32, 16, 8, 4, 2, 1. So basically, you need to add these together to get the total number of matrices. Therefore, you will have another new geometric sequences. You have U sub 1. This time, let's use A sub 1 equals 256. R equals 1/2. How many terms you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So n equals 9. Then we need to add this together. That equals, we use this formula because these are less than 1. So you will have 256, 1 minus 1/2 to the 9th power over 1 minus 1/2. You will get the 511. Let's go to 6a. Consider the sequence like this. Calculate the exact value of the 9th term of the sequence. According to given sequence, we know U sub 1 equals 512. R equals 128 over 512 equals 1 over 4. Therefore, for the 9th term, we use this formula. U sub 9 equals 512 times 1 over 4 to the 9 minus 1's power equals 0.078125. 6b. Calculate the least number of terms required for the sum of the sequence to be greater than 682.6. Since this R equals 1/2 less than 1, we use this formula. So we set up S sub n equals 512 times 1 minus 1 over 4 to the nth power over 1 minus 1 over 4. It's greater than 682.6. Let's simplify. 1 minus 1 over 4, that is 3 over 4. Both sides, let's multiply by 3 over 4. You will get 512. 1 minus 1 over 4 to the nth power. Then greater than, we put into graphing calculator, you will get 511.95. We got to use the equation solver. So we need to change this inequality equals to 0. Therefore, you will get the 512 times 1 minus 1 over 4 to the nth power minus 511.95 equals to 0. You will get the n equals 6.66. So this n equals 7.